Hello again. Hope everyone is having a good spring break and safe, and you guys healthy. This pandemic is just, screwing everyone's plan. So, but at least we thank God that we're still alive and we're still healthy. And I hope you and your loved people are healthy as well. I've got a quick question from my student talking about, well, what about if I have something like this? And that was according to his question 3 kips. There is a UDL, 2 kip per linear feet. It's just K, but it's just a funky K. Promise, this is K. So this is question from one of my student. He did not want me to tell his name, so I'm just keeping his name. But that's his question. Well, and he's thinking about, what about if I want to find this deflection? For example, this is B, and this is C, this is A, and that is 3, yep, 3 feet, 3 feet. And I think the problem out of the textbook, let me just bring the textbook that I have. Here is the textbook that I do lecture from. So I will probably put it in my reference or description of the YouTube video. So if I'm trying to find out what is deflection here, what is deflection at C, obviously this is what I'm thinking. A lot of people has been telling me, well, could you have a set of statics all together in one, basically YouTube, not obviously one individual, and like one category or one list. Just, open that list automatically, autoplay 1, 2, 3, 4, 5, 6, and that is definitely one of my plan. But at least for now, we need to cover the rest of the chapters for my students to just make sure that they are good to go. Anyways, well, again, I also brought an eraser. Some people told me, like, well, could you bring an eraser? I was like, well, okay. So let's do fun, and let's find out what would be the reaction at A. So this is statics again. Sum of the forces in the y direction equals 0. That gives you 2 times 3 minus 3 plus AY equals 0, right? So AY equal 9 kips. And if I do silly mistakes, algebra, please let me know, because I don't typically prepare for the video. Just, kind of, sort of people telling me gifted with this. So that's what I've been doing. Sum of the moment at A, for example, is equal 0. So we have MA, free body diagram looks like your MA is here, you have AY, and you have AX, right? AX is 0 just by inspection, minus 3 times 6, 3 times the entire length, this is 6 feet, right? Going clockwise, boop, boop, right? And then you have minus 2 times 3 over 2. So that is 6, 9, 9, nope, 18, that's 27. So let's do that one more time. 2 cancel out, 9, 27 kip feet. So kind of like structural engineers typically weird with their notations and with their superscripts, with all that thing. So this is kip feet. Kip times feet. This is kips. We do superscript instead of just a normal thing. So let's see. Wait, that is counterclockwise, so that's right. That's 27 cube feet, and that is 9 cubes. I assume that if you are watching my video that you are good to go with statics. So I did not emphasize the steps of statics that much. According to people, that we need just 20, 30 videos, 10 to 15 minutes talking about statics, and we'll do that for sure. So hopefully by this summer everything will be, you know, posted on YouTube. So let's get going. Don't want to erase the fun part, right? So I'm gonna keep it on the board because it is so much fun. So well, if I am cutting a section right there, I think you probably will tell me, Newton, well, you told us that if you have this continuity point, you want to cut it here. Yes, you could, for sure. So if I'm cutting a section here, I'm going to call it NN. So sum of the moment at NN, counterclockwise positive, I've got cross-Hardy method, moment doing counterclockwise. So moment of x, and then you have a minus a times x, 9x, and you've got also what? You've got this plus 27, and you've got this too. So you've got plus 2 times this distance, which is what? The whole thing is 6. So this is x. So this thing is x minus 3, right? This is x. This is 3. This is x minus 3. And this is what? Or this is 3, I'm sorry. This is 3. So this is x minus 3. Right? Then you multiply that by what? By half of this plus this. So that will be x minus 3, half of that, plus this, which is 3. Right? So m of x equal, is it plus or minus? It's going this, counterclockwise, so we're good with that. So that's equal to 0, right? So I want to solve m of x equal 9x minus 2x minus 3 squared, 2 cancel out, minus 6x minus 3, and then you have minus 27, right? That's your expression. Minus, so let's do that one more time. 9x minus 27 minus 2 times x minus 3 times this, so this cancel out, x minus 3, and then you have 2 times 3, that's 6, move it to the other side, negative 6, x minus 3. Okay? So now I could just erase that. Just put it on top. And write down my equation, m over ei equals second derivative of deflection. I have fixed end, right? If you don't know what is fixed end is just cantilever, is this thing. Right? So you have a deflection equals 0, and at this location is 0. And you have your rotation equals 0. So it looks like this. So there is no deflection and there is no rotation. So that makes our life kind of like easier. So we're going to take a derivative of that and or basically once we integrate it, take the derivative of that and set it equal to 0. So m is again 9x minus 27 minus x minus 3 squared minus 6x minus 3 all over EI equal the second derivative. Right? So, well, we could keep EI constant. EI first derivative, so I've got to integrate that. That's 9 over 2x squared, power rule, minus 27x, minus, this is x minus 3 to the third, over 3, minus 2, so that would be 3x minus 3 squared. I'm just adding and dividing by the new power, right? The n plus 1 thing. So, plus, obviously, plus c, we forgot that. Plus c. Now, y prime of 0 is 0, so that's 0, 0, 0, minus 27, actually positive over 3, minus 3 times 3, so that's 9, plus 6, so that is 27 over 3, that is 9, 27, so c equal 18. So your EI first, or not first, I should say, y of x, the deflection, is 9 over 2 over 3, so that's 9 over 6x to the third, minus 27 over 2, x squared, minus x minus 3 to the fourth over 12, minus 3 over 3, so that's 1, right? X minus 3 to the third, plus this, 18x plus c2. So I know a lot of you told me to bring a new board, a bigger one, or just attach two together. That is definitely going to happen. But with this, you know, unprecedented thing, it's kind of hard to do that. So once everything goes back to normal, I will definitely do that. So now we plug 0 in x to find out what is C2. It's a good one. So 0, y of 0 equals 0, that's your BC, remember? Your initial condition or boundary condition, whatever you want to call it. 0 equal 0, 0, minus 3, or 3 to the fourth is what? 81, right? 81 over 12 minus 0, that's plus 27, plus 18, 0, C2. So C2 equal 27, so that's minus 27 plus 81 over 12, so which is negative 27 times 12 plus 81 over 12, whatever that constant is. So that is 27 times 12 is what? Is this, and then you have this, and then you have this, so that is, right? Yep. So, and then that's minus, and then you're gonna do that, so that's 3, that is 4, 2, not mistaken. And if you divide by, the point is not, I'm not teaching you math, right? I'm just teaching you how to do the math part to get to the real thing that we are doing, if that makes sense. So getting this back to this, so that should give you the elastic curve equation. And I don't think nobody wants to see how I'm gonna plug 3 in this to get the deflection at that end. Remember, it was like something at this. So this is the total or the final elastic curve equation, and then you could plug any point to get what is deflection at your interest point. That was helpful. Please let me know if you are confused. Also let me know. I provided my number and my email address, so don't hesitate to give me a buzz. And if you have any questions, not regarding this, just in general, please let me know. We could cover that on the board and have it for basically for good and for free. I will see you soon, and we'll sign out for now. Peace. Bye-bye.